Hello, my name is Bruce Whitfield, and this is homework 5. This is a D flip-flop VHDL code. Right here, I've declared an entity for the D flip-flop with the inputs D and clock, and they are in standard logic, and the outputs are Q and Q bar, also in standard logic. Then I've set up the architecture with a signal. Now this signal will hold the Q value throughout the process. When you begin, I have the process, and the clock is synchronous. Go down right here, and this if statement right here is waiting to detect a rising edge. And if it does, then temp is equal to D, and then at the end of the if and the end of the process, Q is equal to temp and Q bar is equal to not temp. Now I will show my test bench. Alright, so this is the test bench for the D flip-flop. I have set up an entity right here, and I have set up the architecture right here, and I have the signals for the test bench, and the signals are the inputs and outputs of the D flip-flop. I have created a component. The component is the D flip-flop, and its inputs are D and the clock, and the outputs are Q and Q bar. This is creating the component. Down here, I'm instantiating the D flip-flop component, which begins the process. Now, these are the possibilities for the D flip-flop. Now the D flip-flop, it responds to the rising edge. So you have clock is 0 and D is 0, and you wait 10 nanoseconds, and then you have your rising edge, and then D equals 0, and then so on and so forth. Next, I will show the waveform. Now, the waveform right here, whenever D is 0 and the clock is 0, so the clock isn't enabled, there are undefined values for Q and Q bar. Now when D is 0 and clock is 1, Q is 0 and Q bar is 1 because the clock is enabled, which is allowing the data to flow. When D is 1 and the clock is disabled, nothing happens and Q and Q bar stay at the same value. Next, when D is 1, clock is 1, D gets passed through the flip-flop, which results in Q being 1 and Q bar being 0. This is the end of the D flip-flop VHDL question.